Hello, we are going to learn about circles and arcs and the parts of circles. Some of this you've learned before, some of this is going to be a little bit new. So let's get started with the vocabulary that you might be familiar with. For example, a circle, by definition, is the set of all points in a plane that are equidistant. Now, we may not have talked about the word plane yet, but that just is a term that means kind of all in the same flat surface. So we're not talking about something three-dimensional here, we're talking about something two-dimensional. Equidistant from a given point called the center. So picture if you have a point, that's the given point called the center, and you draw all the points that are, let's say, 2 inches from this center. I go 2 inches this way and I put a point. I go 2 inches this way and I put a point. 2 inches here, put a point. 2 inches, 2 inches, 2 inches, 2 inches, all the way around, all the points that are, in this case, 2 inches away from the center. That makes a circle. So that's the definition of a circle. That 2 inches is significant. That's really basically determining the size of the circle. A circle is named by its center, so this circle that we have an example of right down here is called circle P because the center point is called P. A diameter of a circle is a segment that contains the center of the circle and has both endpoints on the circle. So in this diagram, AB would be a diameter because it goes all the way across the circle through the center. The endpoints of the segment are right points on the circle. A radius is a segment that has one endpoint on the circle, one endpoint at the center and the other endpoint on the circle. So over here, the radius would be from point P to C. So PC is a radius. It turns out that a radius is half of the diameter. You've probably remember learning all about that before. All right, the circumference of a circle is basically the distance around the circle. It's kind of like the perimeter, but when we're talking about a circle, we call it the circumference. And the formula for that is 2 times pi times r, where r is the radius. So 2 times the radius, which if the radius is half the diameter, another way of writing this is pi times the diameter, because 2 times the radius would give you the diameter. Pi is that irrational number, the ratio of the, where was I going to write rational? The number pi down here is irrational. So you cannot write it as a terminating or repeating decimal. We'll talk more about pi in class. So pi is the ratio of the circumference of a circle to its diameter. So if you take the distance around a circle and you divide it by the distance across the circle, you will always get approximately equal to 3.1415, etc., which is pi. So we've talked a lot about ratios with similar triangles and everything. Well, circles has this special relationship. Circumference divided by diameter will always give you pi, 3.14. Okay, so that should be things that you're familiar with. This next part might be some new vocabulary. A central angle is an angle whose vertex is the center of the circle. So in this diagram over here, I can take O as my vertex, and if I draw an angle with O as the vertex, like this, that would be called a central angle, this angle right here. So for example, angle LOK is a central angle. All right, congruent circles, circles that have congruent radii. Actually, they have congruent everything. They have congruent diameters and everything. We've talked about congruent before. An arc is just a part of a circle. Now, remember, a circle is just the points that go around a center, right? So a part of a circle would just be a section of that line, basically. We're not talking about anything like a whole wedge. We're talking about, if I always refer to this as kind of like a pizza, the arc is like the crust of the pizza. It's just that edge part, and the circumference goes all the way around, but an arc is just from one point to another point on the circle. So this would be an arc. Over here, LK would be an arc, right? So arc LK. The notation for arc, we put an arc, basically, over the 2 points that are the endpoints of that arc. So we would write it arc LK. It's a part of a circle. I'm just going to write here, it's like the crust of the pizza. Okay? An intercepted arc is the part of a circle that lies in the interior of an angle. We're going to learn different types of angles, but let's take central angle because that's what we've talked about today. This is the central angle, LOK. The intercepted arc would be arc LK. So maybe right here we'll say LK, arc LK, is the intercepted arc of angle LOK. Okay, so you can copy that down onto your notes too. All right, a semicircle, another vocabulary word here. A semicircle, you've probably heard of before, is an arc whose endpoints are the endpoints of a diameter of the circle. So it's really half a circle is a semicircle, 180 degrees. Remember, circles go 360 around, 360 degrees around. A semicircle is half that, 180 degrees around. A minor arc is an arc that is less than a semicircle, less than 180 degrees. So a minor arc, we're going to name it this LK that we used up here. We just use 2 endpoints and we put that arc over it. Now, when we get down to this next word, major arc is going from 2 points on a circle, kind of going around the long way. So L to K is the minor arc. We go straight from L to K, the shortest distance. If we want to go the long way from L to K, we might start at L and go around through J and end up at K this way. See what we're doing here? So that's called a major arc, and it's an arc that is more than 180 degrees or more than a semicircle. When we do that, we need a different notation because if I just call that start at L and end at K, people are going to want to go the short way. To tell people that you want to go the long way, you've got to start at L, go through J, and end at K. So you're actually going to use 3 points to name that arc. So whenever you see an arc named with 3 points, that's going to be a major arc or a semicircle, actually. Let's just make that notation here for semicircle. Let's say use 3 points for the semicircle also. Okay? All right, adjacent arcs, you know what adjacent means, right next to each other. Adjacent arcs are arcs of the same circle that have 1 point in common. So if I do an arc here and then continue with another arc right next to it, those are called adjacent arcs. And then concentric circles are circles that have the same center. So if you throw a rock into a pond and you have the ripples that come out like this from the rock, all of these are concentric circles because they have the same center. Also, you might think of like a target or a bullseye. All right. So this next piece right here is just getting you to practice using some of these terms. An example of a diameter from this diagram would be, let's say, AE. Now, a diameter is a segment, so you're just going to put a segment symbol over it. Another diameter would be BD. A radius would be anything with C as an endpoint. So CE, CD, CA, CB, etc. A central angle, maybe angle ACB. Anything with C as the vertex, angle ACB or angle ACD. These are all central angles. There's more there too. A semicircle, remember half a circle. So here's a diameter. AB is a diameter. Half a circle would be the intercepted arc of that diameter. So semicircle ABE is the semicircle that I just highlighted right there. ABE, remember 3 letters. A minor arc would just be going the short distance from one point to another, so maybe DE. There's other answers that could be here. And a major arc, let's go from D to E the long way. D around to E, and we can pick any of the points in between, but you're just going to use one of them. So I'm going to call it DAE. That's a major arc. Okay, so this is just kind of a recap of talking about the arc measures as they relate to the central angle. So remember what we just talked about with a central angle is an angle that has a vertex at the center. And we talked about the intercepted arc is the piece of the circle that is in the interior of that angle. So if you kind of think about this angle as like chopping off a part of the circle, that piece there is the intercepted arc. Well, there's this relationship between the angle measure and the arc measure. We can use degrees to talk about the measure of the arc, just the way we can talk about degrees as the measure of the angle. And this basically says that the measure of a minor arc is equal to the measure of its corresponding central angle. So you would say that since this angle RST is 50 degrees, then the measure of arc RT is also 50 degrees. It's just equal to its central angle. And it makes sense because we know 360 degrees around on the interior here is the same going around this way. This is 360 also, right? So it's the same piece of the circle in degrees. By the same concept here, if you have adjacent arcs like we talked about, 2 arcs that are right next to each other, in this case arc AB and arc BC, they're right next to each other. Well, 2 arcs right next to each other are going to be able to just be added together. So it's kind of like segment addition postulate or angle addition postulate. We said if we have, a segment like ABC like this piece AB plus this piece BC equaled the whole length AC, right? So if it was 2 here and 5 here, the whole thing would be 7. Just imagine sort of wrapping that around a circle now. If this arc is, let's say, 30 degrees, and this green arc is 150 degrees, then the whole thing would be arc ABC, then the whole measure of that whole arc would be 180 degrees, adding 30 plus 150. Okay, so I'm going to do this one practice with you here, and then you can pause the video and practice these on your own, and then turn the video back on, unpause it, and check your answers. But let's do this first one together. What are the measures of arc, PR, RS, etc.? Well, arc PR, if this central angle is 77, then arc PR is also going to be 77. RS. Well, in order to get RS, we need to know what this central angle is. Well, how are we going to get that central angle? Well, there's always some hints in these circles. This is a diameter. It's going straight through. So therefore, this whole arc PRS would have to be 180 degrees. Well, if the whole thing's 180 and this piece of it is 77, I'm going to do 180 minus 77 and I'm going to get 103. So if angle RCS is 103, then arc RS is also 103 degrees. All right, the next one asks for arc PRQ. Well, PRQ goes from P through R, end at Q. Well, we said PRS is 103, and now we have SQ is 28, so we're just going to do 103 plus 28, and we're going to get 131 degrees for PRQ. All right, and then PQR. Let me erase this piece here. PQR goes from P, don't forget, this gives us directions. It starts at P, goes through Q, it's 3 letters, right? So we're going to go the long way, and end at R. PQR. Well, that's pretty much everything except the 77-degree arc, right? We said this is 77. So that's everything except the 77. So I'm going to do 360, which is the whole circle. I'm going to subtract the 77, and I'm going to get 283 degrees for PQR. Okay, so when you're doing things like this, look for clues. Sometimes you have to add things together, sometimes you have to subtract them. Sometimes a clue is finding a diameter and sort of looking for linear pairs or whatever in there. Okay, so pause the video and try to do these on your own, and then turn the video back on to check your answers. Okay, so check out your answers and compare them. If there is a etc., that means that there's really more than one answer, more than 2 answers. There's maybe lots of answers. Everything else is pretty much set the way the answer is written, except remember with segments, all of these could be the opposite way. You could have FG, HG, IG, JG, etc. And the same with semicircles. You could have it in reverse, IHF or IJF, or you could have IH for this minor arc, or HF, etc. So if it says etc., that means there's really more than one answer, or more than these answers listed. And if it doesn't, that means the answer is what it is. Okay. Thank you, and we'll see you soon.